Hello students, today we will discuss another new chapter, that is work, power and energy. Very interesting chapter. In the previous classes we have done motion, laws of motion, and today we will discuss work, power and energy. Before we start work, power, energy, first we have to know what is work. Generally, reading is a work, we know, we say, not we know. Writing, work, these things are not said to be work in the physics. Physics tells that when a force is applied on the body and the body travels in the direction of force, then work is said to be done. What is work? If a force is applied on a body, and the body is displaced in the direction of force, then work is said to be done. Let us suppose this is an object, a force is applied on it, and the object is at position A. After applying force, the object is displaced to position B. Direction of force is from A to B. Displacement is also from A to B. In this case, let this displacement is S. So work done is equal to force into displacement. Force into displacement. Work is said to be done when a force is applied on a body and the body is displaced in the direction of force, then work is said to be done. If force is applied on a body, but there is no displacement, then work is not done. Suppose we will push a wall. We apply force on the wall, but the wall do not move, do not displace. Hence, in this case, work is said to be zero. Work is said to be zero work done. Similarly, when we will consider a coolie, he walk along the platform with some luggage on his head. In this case, the work done with respect to force of gravity, is zero. Total work done is not zero. In some books, it is written that the work done by the coolie is zero. It is not correct. The work done by the coolie with respect to force of gravity is zero. Why? work done is 0 in two cases. First case, when displacement is 0, although the force is applied on the body. Second case, if displacement is perpendicular to the direction of force applied, then also work done is 0. In two cases, work done will be 0. Though force is applied, if displacement is 0, then work done 0. In second case, if the force is perpendicular to the direction of displacement, if the force is perpendicular to the direction of displacement, then also work done 0. Why in this second case work done 0, that we will discuss now. Before we discuss the second case, let us discuss what is the unit of work. Now we know work done equal to force into displacement. SI unit of force is Newton. And SI unit of displacement is meter. SI unit of work is Newton into meter, that is equal to joule. It is named after the scientist Joule. That means 1 joule is equal to 1 Newton into 1 meter. Or we can write 1 Newton meter. 1 Newton meter. CGS unit of work is org. 1 org is equal to 1 dyne into 1 cm, or we can write 1 dyne cm. Dyne cm. Now this thing I will erase. How can we define 1 joule? If the force of 1 Newton displaces a body through 1 meter, then work done said to be 1 joule. How can I define 1 joule? Here another question. 1 joule equal to 1 Newton into 1 meter. In the chapter laws of motion, we know 1 Newton equal to 10 to the power 5 dyne. 1 Newton equal to 10 to the power 5 dyne. 1 meter equal to 10 to the power 2 cm. Now we can write this. If a to power x into a to power y is there, we can write a to power x plus y. 10 to power 5 into 10 to power 2. 10 to power 5 plus 2. 10 to power 7 dynesium. But we know dynesium equal to arc. That means 10 to power 7 arc. Therefore, 1 joule is equal to 1 joule equal to 10 to the power 7 arc. 1 joule equal to 10 to the power 7 arc. Now, how can we define 1 joule? If force of 1 Newton if a force of 1 Newton displaces a body through 1 meter, then work done is said to be 1 joule. Work done is said to be 1 joule. If a force of 1 Newton displaces a body through 1 meter, then work is said to be 1 joule, or 1 joule equal to 1 Newton into 1 meter. Similarly, how can we define 1 erg? 1 erg we define if a force of 1 dyne, if a force of 1 dyne displaces a body through 1 cm, one meter, if a force of 1 Newton displaces a body through 1 meter, we write in the direction of force. In the direction of force. This is the main point. In the direction of force. Here also, if a force of 1 dyne displaces a body through 1 cm, in the direction of force, in the direction of force, then work done said to be 1 erg. Work done is said to be 1 erg. 1 erg equal to 1 dyne into 1 cm. 1 erg equal to 1 dyne into 1 cm. And relation between joule and erg is 1 joule equal to 10 to the power 7 erg. 1 joule equal to 10 to the power 7 erg. Now we will discuss why the work done is 0 when displacement and force are perpendicular to each other. The second case now we will discuss. Understand these things? What is the definition of work? When work is said to be done? And what is the SI unit of work? What is the CGS unit of work? And relation between SI unit and the CGS unit we discuss. Now we will discuss first case. We know that when displacement is 0, although force is applied, then F into S, F into 0 equal to 0. But in second case, I have told that when force and displacement are perpendicular to each other, then work is said to be 0. Why this? Let us discuss. This is an horizontal plane or surface. A body is here at position A. A slanting force F is applied on the body, but the body not displaced in the direction of force. The displaced force is applied in this direction, but body is displaced horizontally and reaches at B, and this distance is S. Now we have to find out what is the amount of force in the direction of displacement. What is the magnitude or amount of force that act along the direction of displacement? That we have to know. To know this, draw a perpendicular from this point C to the D. Let this force is applied on the body at an angle theta with the horizontal. Understand? This force is acting at an angle theta with the horizontal. We have to calculate what is the amount of force in this direction, in the direction of displacement. In the direction of displacement, what is the amount of force? To know this, we should have idea about the trigonometry. Now, I will discuss a very shortly the trigonometry. Trigonometry based on right angle triangle. There are 6 trigonometric ratios: sine, cos, tan, cot, sec, cosec. We know the sum of angles of triangle is 180 degree. One angle is 90 degree. The sum of these two angles is 90 degree. Sum of these two angles 90 degree. Let this angle be theta. Then if sum of these two angles 90 degree and one angle is theta, then this angle be 90 minus theta. What this angle will be? This angle will be 90 minus theta. If we find the trigonometric ratios of this angle, sine theta is equal to opposite side by hypotenuse. That means AB, this is the opposite side to the angle theta. This angle and the side AB are opposite to each other. Hypotenuse, the side opposite to right angle. The side opposite to right angle is hypotenuse, and it is the longest side of right angle triangle. Hypotenuse is the longest side of right angle triangle. In class 8th, we know the square of hypotenuse of right angle triangle is equal to the sum of square of other two sides. That means AC square equal to AB square plus BC square. AC square equal to AB square plus BC square. And AC is the longest side. Sin theta equal to the side opposite to the angle by hypotenuse. The side opposite to the angle by hypotenuse. And the side opposite to the angle that we have taken, that we represent as a perpendicular by altitude or altitude. P, B, H. Sin theta equal to opposite side by hypotenuse. AB by AC or P by H. Cos theta equal to adjacent side by hypotenuse. The side adjacent to the angle is BC. That we can write as B by H or BC by AC. Tan theta equal to opposite side by adjacent side. Tan theta equal to side opposite to angle and side adjacent to the angle. AB by BC. Cot theta is the reciprocal of tan theta. Cot theta is the reciprocal of tan theta. We can write reciprocal of these things: adjacent side by opposite side. That means BC by AB. Sec theta is the reciprocal of cos theta. Hypotenuse by adjacent side means AC by BC, or we can write H by B. Cosec theta is hypotenuse by opposite side, which is the reciprocal of sin theta. Cot is the reciprocal of tan theta. Sec theta is the reciprocal of cos theta. And cosec theta is the reciprocal of sin theta. That equal to H by P or AC by AB. These are the 6 trigonometric ratios. Sin theta equal to opposite side by hypotenuse. Cos theta equal to adjacent side by hypotenuse. Tan theta equal to opposite by adjacent side. Cot equal to adjacent side by opposite side. And sec equal to reciprocal of cos. Cos equal to reciprocal of sin. Now we apply this in this figure. We have to calculate what is the component of force that act along the direction of displacement. What is the component of force that act along the direction of displacement? This is the adjacent side of triangle and this is the hypotenuse. If we find cos theta, adjacent side by hypotenuse, cos theta is equal to adjacent side by hypotenuse. That means AD by AC. In AC we take F. So AD, in the direction of AD, what is the component of force? F cos theta. You cross multiply it. Component of force in the direction of AD is F cos theta. Therefore, work done is equal to. Now I will erase it, this trigonometric concept. work done is equal to force along the direction of displacement into displacement. Now we find force along the direction of displacement is F cos theta. Force along the direction of displacement is F cos theta. And displacement is S. Therefore, work done equal to, we can write Fs cos theta. So, this is another formula to obtain work done. Now, if we find the values of trigonometry, some standard values are there. Sine, cos, 0, 30, 45, 60, 90. Sine 0 value 0. Sine 30 value 1 by 2. Sine 45 1 by root 2. Sine 60 root 3 by 2. Sine 91. Similarly, if we take here 180, sine 180 0, cos 0 1, cos 30 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0, cos 180 minus 1. If case 1 you would consider, if theta equal to 0, then cos 0 equal to 1. If we put cos 0 equal to 1. So W equal to what we will get? Fs into 1 Fs. And this is the maximum work done when the angle between force and displacement is 0 degree. Case 2, if theta equal to 90 degree, cos 90 equal to 0, cos 90 value 0, that means work done F into S into 0 equal to 0. Now you clear why the work done becomes 0 when the angle between force and displacement is 0, 90. When the angle between force and displacement become 90 degree, the work done becomes 0. This is the reason. If theta equal to 180 degree, cos 180 value minus 1, that means work done is equal to Fs into minus 1 minus Fs. That means negative work done. This is the positive work done, this is 0 work done, and this negative work done. And we will give the examples of positive work done, 0 work done, negative work done in the next class. And I hope that you will comment and you will give the answer in your message box. I expect these things from you. These things about only work. In the next class, we will discuss about the power and energy. If you like my videos, then you share it and subscribe it, by which I will inspire to make more and more videos for your better things. Goodbye. Thank you.